Hey guys, in today's lesson, we're just going to do some more practice problems, specifically with word problems. So some of these are exponential growth and some are exponential decay, and you'll just have to determine which one is which, depending on the situation. So I'm just going to do a few of these with you, and then you're going to practice on your own. So number one, in 1995, there were 85 rabbits in Central Park. The population increased by 12% each year. How many rabbits were in Central Park in 2005? So since it's talking about the population increasing, I know that this would be an exponential growth. So I'm going to write my formula for exponential growth. So that's going to be that y equals c times 1 plus r to the t power. So C is the initial amount, and so it says that they started off with 85 rabbits, so C is going to be 85 times 1 plus. Now R would be my rate. Okay, I don't know why it's not. I'll just show stuff. There we go. It says it increased by 12%, so that's going to be 0.12 as a decimal, and then to the t power, how much time? Well, we started off with the amount in 1995, and then we end up with, we're asking how many are going to be in the park in 2005. So from 2005 to 1995 is a period of 10 years. So for t, I'm going to put a 10. And I'm just going to type that into my calculator. Again, I'm going to use my graphing calculator. Any calculator, well, not any, but most calculators would probably work. If you don't have a graphing calculator, then you can certainly use Desmos. So 85.1 plus 0.12 to the 10th power. And we're talking about rabbits here, so you can't have a part of a rabbit. So we're going to round to the nearest whole number. So that's going to be 264 rabbits. Okay, so that's number one. Let's going to do a quick scan. I want you to also let's underline the word increased, and we know that that was exponential growth. Oops, there we go. And let's see if we can scan one that is exponential decay. So let's see here. Okay, let's skip down to number 6 real quick, and we'll practice this one together. It says, Kelly's mom takes a 400 milligram dose of aspirin. Each hour, the amount of aspirin in a person's system decreases by about 29%. So I'm going to underline the word decreases. To the nearest tenth of a milligram, how much aspirin is left in her system after 6 hours? So first, this one's going to be exponential decay. I'm going to write that down over here. And I don't know if you've noticed, but all these exponential growth and exponential decay problems, they all have a percentage in them. So they're all dealing with a percentage. So that's also a clue that it's exponential. Okay? So for exponential decay, our formula is y equals c times 1 minus r to the t power. So c is going to be the initial amount, and it said that her mom took a 400 milligram dose. So 400 is my initial amount. 1 minus. My rate is 29%, so as a decimal, that's 0.29. And t is my time in hours would be 6. And so be really careful. That 29% is saying it decreases each hour 29%, so you want to know 6 hours. Okay, so now I'm going to type that in. So we'll type 400 times 1 minus 0.29 to the 6th power. And they did tell me to round to the nearest tenth of a milligram, so that would be 51.2 milligrams of aspirin left. Okay, so I actually am going to have you practice these now. So you're going to do 2, 3, 4, and 5 on this page. and then 7 through 10 on the next page. So pause the video and do the remaining problems on both pages. Make sure you're showing your work, and then come back and we'll check. Welcome back. So now you're going to check over your answers to the problems that you were just working on. So here are the solutions for problems 2, 3, and 4. So you can pause the video and make any necessary corrections. And here we can see problem 5. I'm going to turn the page, and we can see 7 and 8. And then, let's see, here's 9 and 10. 9 is at the top. Oops, there's 10. Hopefully you've done well with these problems. If you have any questions, remember to ask me. I'm happy to help. Once you've submitted this, go ahead and complete your independent practice.